Hello and welcome to another video. I was supposed to get this released perhaps over a week ago, but this didn't turn out to be as nowhere near as easy as I thought it would be. And then in the middle of making this video, I found another Slotket, just the same, exactly the same kind, same revision. So I ended up modifying two Slotkets so I can use them with Tualatin CPUs, including the C3 from VIA. The first one, it has 9 jumpers. Basically everything I did is behind the jumper. The second, it only has 5 jumpers. Well, I did testing with this first one and made easier modifications for this second one. And why this was so hard? Well, something just was hard. You'll see on the video. But what was perhaps the hardest is that there wasn't very good information how to do this. And since these have jumpers, the idea was that I can use PPGA Celeron, Coppermine CPUs and Tualatin CPUs with one Slotket. So I didn't want to lose any functionality. Every information I found, all the guides were from back in the day, written in a way that you have this motherboard, slot 1 motherboard, and you want to use the latest Pentium 3s with it. But we're not in that era anymore. This retro computing stuff is a little bit different. So one day you may want to test PPGA Celeron, then you want to compare it with Coppermine and of course Tualatin and use whatever happens to be best to whatever scenario you build your system and so on and so on. And some of those guides, well, none of them have designs with jumpers on them. So it was basically you now must use Tualatin CPUs because why would you want to use anything older? But there was other issues as well. Well, they simply sorted TTL voltages to core voltages. And on Tualatin CPU, when used on this slot 1 system, they are pretty much almost the same. But I still don't think that's a good idea to just sort different voltage sources together. So I wanted something cleaner. And one guide was above the other, but it was written in Russia and there was no English translation. But fortunately, Vivaldi web browser had built-in translate that did actually quite a good job. It was not perfect, but understandable. And it explained a lot of things, but it still left some questions. And actually I still have some questions, but these Slotkets work. They work with Tualatin and VIA C3, Nehemiah and Ezra-T. And of course Coppermine and PPGA Celeron support is there and tested. I'm first going to do the one with 9 jumpers, just to experiment everything. And then I modify the design so that there's only 5 jumpers. And in fact, if you want to lose PPGA Celeron support, you could do it with 3 jumpers. But it won't be much easier, so I don't think there's any point to lose the PPGA Celeron support. Let's let's see what we have to do. Here is the PPGA Celeron Pinout. But if we apply changes that the Coppermine Pentium 3 did, most of these are VTT voltages, and that's 1.5 volt signaling voltage. And really there's not that much difference. Here is the key pin that prevents Coppermine Pentium to work on a PPGA Celeron Slotket. Here is the, let's see, yeah, this bottom one was the original PPGA Celeron reset, and it was moved here. Of course, these changes are completely intentional, that you cannot use Coppermine on a PPGA system, because I think it was originally meant for the low-cost motherboards and low-cost systems. I suppose those VTT voltages, because there's now several pins more. And on the PPGA Celeron, I think this 1.5 volt pin is the only VTT voltage pin, even though there were 4 pins on the slot 1. But for some reason, Intel decided to use only one for the PPGA Celeron. And on Coppermine, well, there's quite a lot. So perhaps the one pin wasn't simply enough, but who knows. And then if we take the Tualatin changes, again there's actually even less changes than what the Coppermine did. There's a couple of more VTT lines, yes, pins, but really that's not that many, and they are routed together on the CPU package anyway, so it's not even needed. And it's mostly intentional changes that prevent you to use Tualatin CPU on a Coppermine motherboard. Let's soon take a closer look what we need to modify, but there is one change that is so important that perhaps that could have alone be a reason why Intel wanted to prevent Tualatin CPUs to be used on older systems. And it's this. It's VID 25 millivolt on the Tualatin Pinout. But if we take look, actually it says these are Intel Pinouts. So it says it should be grounded. But really that's the voltage ID pin 4. That was the most significant voltage bit on earliest slot 1 CPUs, Pentium 2 and I'm sure Pentium Pro's Slotket as well. So I never seen those, but I'm sure they used such high voltages, because you don't really need this at all. It's always 0 for every socket 370 CPU starting from the very first Celeron. But Slotkets, of course, they route the voltage ID pin 4 here. Not all, but most of them do. And since on Tualatin it's least significant voltage bit, only 25 millivolts, you will get serious overvoltage if your motherboard handles this as a most significant voltage bit. So this change alone could have been reason why Tualatin doesn't work on Coppermine systems. But of course they could have used some reset pin for this, so it's more or less intentional anyway. What we have to do, first we have this dynamic output enable. It's connected to ground on these older designs, but now we want VTT voltage, and this may be optional. I'm using this rom.by article. I'll put links in the description. That's in Russia, so I have to use machine translation, and Vivaldi web browser has built-in translation that does actually quite a good job, so it's understandable, not perfect but understandable. Apparently connecting this to VTT, if I understand this correctly, should prevent your CPU, Tualatin CPU, to try to boot with all voltage ID pins set. That would basically means no voltage. But I'm not sure it actually does that, because we are going to have to ground voltage ID 4, that's this. So it's always ground. This was most significant bit, voltage ID bit on the earliest designs. And this will was the detection with all voltage ID pins set, so that this is 0 and this is interpreted as 1.3 volts. Apparently this dynamic output enable should prevent those false voltage IDs set, but it doesn't seem to, at least not on the one CPU I have. But we'll take a look at that later. But this, I'm going to make this first design so that every modification is behind single jumper. And then we do optimized design with less jumpers later. But this is what we'll do first, and this is what we'll try first, and based on what we found, we'll optimize this. This jumper, now in this position, this is the Coppermine PPGA Celeron position, where rounds gets to it. And now, here is the hardest part of this mod, because it's already ground, and it's connected to ground on the inner layers of the PCB. You can't simply cut a trace, but you have to isolate the pin completely. There's a couple of ways to do that. We'll look at those later while actually making the mod. But the isolation, that's the hard one. When you can do it, you can simply solder wire to the pin, and the other location of the jumper sets this ground, and the other sets VTT voltage to it. And the rom.by guide, well, of course every guide I found, they just did this mod so that you don't have jumpers. It's Tualatin only after these modifications. And obviously, if you are connecting voltages where there was ground, of course it will cause issues without jumpers, so you simply cannot. It will be dangerous to install Coppermine or PPGA Celeron if you just do the mod without jumpers. But I don't want to break any functionality, so this is the way we do things. Hard way, but I hope it will be the better way in the end. Well, let's actually skip one jumper for now, because this is pretty much the same. Exactly the same connection to this VTT power cord, and this absolutely needs to be isolated and voltage applied to it. Otherwise your CPU won't start. And the rom.by guide says that you should place a resistor here for protection in case the isolation isn't perfect or anything like that. And it mentions 0.1 to 0.3 kilo ohm resistor here. Actually, I'm skipping the resistor on this first design, but I'll apply it to later to the second improved design. And you can also use the resistor here as well. This edge control, this is only used by the PPGA Celeron, and the default how it is done is simply you have 51 ohm resistor between core voltage and the pin. And for Coppermine and Tualatin as well, Coppermine doesn't use this edge control at all, neither does Tualatin. But Tualatin, it's now VTT here, VTT voltage this pin. While it would work without modification, it just doesn't feel very wise to connect two different voltage sources together and simply there's a resistor between them. Shouldn't cause any harm, and the current will be very small. But still, I'd isolate this completely, and this is what this jumper does. But this pin is actually easiest to isolate because you could simply locate this 51 ohm resistor on your slotket and remove it, and that should be all you need to do. But of course, when you place the jumpers where you can on your slotket, you're going to need 51 ohm resistor there. This is the jumper 4. This is the voltage ID 4, or rather 25 millivolt on the Tualatin, and this absolutely must be grounded for Tualatin. And I accidentally even tried this on Tualatin without grounding it, and you got 2 volts, but it didn't broke. It was like that only very short time. But yes, you need to definitely set this to ground for Tualatin. And in fact, you can keep it ground even on PPGA Celeron and Coppermine as well. And one of my slotkets, the 8-bit PPGA Celeron slotket, it was permanently connected to ground already. Jumper 5, reset. This is something that you need to isolate simply for Tualatin, because this is one of those intentional protections that you couldn't use Tualatin on an older system. So it's connected to the ground on the older designs, and you simply must isolate it for Tualatin. This voltage ID 2, it's not really part of the mod itself, but rather to fix a glitch, because sometimes the CPU tries to start with all voltage ID pins set, and normally that would mean no voltage, but since we ground voltage ID 4, it turns into 1.3 volts, and that may or may not be enough for your CPU to boot. But if we pause voltage ID 2 to ground, the boot up glitch voltage raises to 1.5 volts, and that certainly is enough. In fact, it could be a bit more than your CPU normally would use, but not so much more than it would make any problems or causes any issues. So it's quite a good voltage. But if you don't have the glitch and your CPU is one that uses 1.4 something, basically less than 1.5 volts, then forcing the voltage ID2 to ground causes normal boot up voltage to be 1.65 volts. And that's a bit too much. Perhaps for a short time it doesn't really matter, but it's something you need to be aware of. You absolutely must set correct voltage from the BIOS setup, but if you still are afraid of the 1.65 volts, well then you would have to modify the voltage ID, what you pause to ground or whatnot, and to whatever your CPU uses. And best thing would be to actually make jumpers for all the voltage IDs. And you may already have a slotket that has those jumpers, and that would be the best kind of slotket. I recommend to set the voltage manually if you can. Now detect. Apparently this, if you do not isolate this might cause some issues on some systems. Apparently Asus motherboard slotkets, at least that rom.by guide mentioned, I did isolate it. It's ground originally on the older designs. So I isolated it and placed jumper. Now this is perhaps the hardest, because there's VCC core voltage on the older designs, or rather Celeron. But now it's VTT on Tualatin. If you are going to use Tualatin CPU, they are going to be very close. They could be even exactly the same. VTT should be 1.25 volts on Tualatin, but since on these older designs it's 1.5 volt, and that's what we're going to use. And the rom.by guide mentions that on the other hand, on Intel datasheets, you have 1.5 volt is within the tolerance, but on the other hand, somewhere it mentions that you shouldn't use it. And perhaps because Intel didn't want you to use Tualatin on these older systems. And these guides are over 20 years old. And I'm sure if CPUs would have got them broken because of these mods, well, there surely should have been some mentions about them. So I suppose it is safe to use 1.5 volt as VTT voltage, because that's what we're going to get. So this might be even the same, depending on your CPU, or this VTT can be a bit more than the core voltage. But I still don't think you should simply connect these together. So I wanted to isolate and place a jumper between them. And the last jumper, this G37, needs to have VTT voltage on Tualatin. It won't start otherwise. And this is only VTT voltage, new VTT pin that requires it. And I placed jumper for it. This is now what we are going to do. I'll start by isolating those 3 necessary pins. This is low met solder based. So it's A and 3, AK4 and HJ3 would be right below it. They need to be isolated because they connected to ground, I think, all of them. This is the hardest part of the mod because they need to be isolated from the ground. They are now connected. And one of them needs to be reconnected, but we'll take a look at that later, because the isolation, well, it would be easy if it would be easy to remove the whole socket. But that's not really easy, because 370 pins need to be desoldered, and there's a good chance you break some of the traces while doing that, and you may not get the pins out intact, and damaging the socket and the PCB is very much possible. Because if I would be able to remove this socket, I could simply drill holes bigger than what they are at the moment, and then fill with, put the socket back on and fill the bigger hole with epoxy or something to isolate, or perhaps even a sleeve from a wire or something. But that's not really possible. What I'm going to do is simply remove all the solder and try to isolate these pins now loose with PCB varnish, and we'll just have to see how that works out. I don't really know, but that's the best I can think of. But first I need to get them completely free of solder. There's simply cannot be any solder left or any connectivity. So all needs to be removed. And let's see how it goes. I'm warming the PCB. This is 300 Celsius at the moment. And the soldering station is 420 degrees. Oh, that looks really nice. This PCB moves around, it's too lightweight. Very good, very good. I seem to have removed much more than I intended. Well, at least But yeah, it's going to be hard. There's not much empty space between the pin itself and the hole. Let's poke with the needle. Yes, completely free. This one as well, and this. This was simply an accident, but that's easy to fix. Now, what I can't see. This feels so free, but it would be ideal if I could somehow measure that there is no connection. But that's going to be so hard but let's try anyways, because this is so big. But let's see, maybe you can see something, I don't know what it connects even with very if I push it down here, then it won't, but in a slightest, maybe it's not completely free from solder yet. This is good, this is very good, I think. Because if I push it, yes, then it contacts, yes. This is now isolated if it's in the center position. What about this one? Yes, this is good also. Very good. But that one, top one, let's apply solder paste. Now it looks better. It just needed more extra heat. I'm using actual PCB varnish, although I don't think it matters really what you put here, as long as it isolates and it isn't too thick, because you are going to need to push it to make sure it actually fills the hole and there's not some air gap. I have this very small wire. I was hoping maybe I could use this, but even this one looks a bit too large for this job, because I'm going to need to push to make sure there is no air gap here. Once I apply the varnish, there's air bubbles easily somewhere at the bottom, because this PCB is thicker than this hole is wide. So, and then I need to make sure these pins are in the middle. So there's varnish all around them. But I suppose I'll just have to try and see how it goes. No, I need to solder that one pin that was desoldered by mistake, because if I now apply the varnish, it goes here as well, and it might make the connection later impossible or very hard. So I just have to fix my mistake. This is so large, this. Very good. I'm going to fix this one because they lost some solder as well. I don't want to take any unnecessary risks. This needs to succeed in first try. Actually, maybe I should find ground somewhere. Yes, now I only need this one. They are grounded. Yes, it doesn't connect from here, but here it does. But the pin doesn't, very good. They move so easily. Maybe it would be easier if I had some CPU here. Now we have CPU in there. Maybe they don't move so easily now. Yeah, I think this is better now when we have CPU in there. This goes where it's not supposed to go, but can't really help it. And now it might be possible that once this has dried, a second time needs to be applied as well, but we'll just have to take a look at that. Oh, now I'm going to push with this very small wire. I want that varnish goes down the hole. It's supposed to fill the hole and not everything around. And this is really the only way to do that. I didn't clean the flux or anything because I don't want any IPA in the hole or anything like that, so I want only the varnish inside the holes. To actually test the conductivity later, I need to test it from the other side of the socket against ground, because of course I can't trust anything here at the moment once it dries up, that because there's so much varnish that it will of course block any connection. No, this wasn't a good idea. Now we'll just have to wait. It's the next day that the varnish has dried, so let's take a look. Yes, pin doesn't move, at least not much. So I'd say looks quite good. But is it isolated? That's the question. And since there's varnish now, I can't just use multimeter. So I need to measure from the other side This is the easiest, I think. And then we need ground. Actually, let's use this black wire as ground over this corner. And this one goes here, or was it here? Do we have a connection? No, we do not, and that's good. At least I hope these are absolutely nothing. Well, maybe, of course, there's always the risk that the varnish got inside, and it did get inside there. But we had CPU installed, so I hope it hasn't isolated the contacts inside the socket. Yes, no connection at all. Nothing, absolutely nothing. So very good. That means the isolation was successful, but the PCB one is, well, you can solder through it, and that's a feature, of course, but it will make hard to solder the wire here, because there's very high risk that I will solder this pin back to ground. So I think epoxy would have been better choice. But there's a question I want to know. First, the guide mentions that these two must be connected together, and they should most likely already be connected together. So let's make sure of that. Actually, they are not. Now it's X34. That's what I'm really interested about, because it's core voltage VCC on Celeron. On Coppermine it's reserved, but on Tualatin it's VTT. And if your Slotket connects VCC and VTT together, well, on Tualatin they are so close that it probably doesn't matter, but I just don't like the idea. So do we need to isolate that one as well? And let's take a look. So, and this is VTT on Coppermine. So let's take a look. Do we have we don't have CPU at the moment here. X34 to VTT. And we do not have connection. And that's of course not surprising at all, because this is reserved on Coppermine and VCC on Celeron. So this is VCC, it's right next to it. And unfortunately they are connected together, because Celeron uses that one, but this means we need to isolate that one as well. I think this microscope is on the way, so I'll just have to desolder it off camera. Yes, now it's free now. Yes, it's good. But before I apply any epoxy, I need to solder those that I removed by accident, because if there's epoxy on top of this. Now let's make some epoxy and see how it goes this time. How to get so little? Now, how do I get it there? Because it's so needle, yes, but well, I guess. All right. And now, with a very thin fire, this is the very same method I used with the varnish, but yeah, I think this is going to work just fine. Yes, but of course I need to be sure that I don't glue the CPU in there. So now I need to wait that it dries. But I'm not going to remove the CPU just yet. I'm going to wait a couple of minutes before doing so. Actually, there's just one pin we might take a look at. It's, let me see, AG1 edge control on the Celeron and Coppermine as well. It seems based on the Intel pinouts, but the document guide says that it's not connected on Coppermines, because on Tualatin it's VTT as well. So do we need to isolate it or not? The guide didn't isolate that one, but you think that it may be a good idea to do so. And in fact we should have cleared it. But if we isolate it, we might need to place jumper for it. And actually we do need to place jumper for it. Let's take a look. Let's play safe and isolate this pin as well. This is edge control on Celerons, and based on Intel pinout it's also on Coppermine, but the guide says this is not used on Coppermine, so not really sure. I'm going to do that off camera because, well, you just saw how I did with this X34. There seem to be quite a lot of things that need to be investigated concerning those VTT voltages, for example. But I want to be sure are those information pinouts correct or not, and so here is my only Tualatin compatible motherboard. This is some compact motherboard with PCB date of quite late, actually. Let's see if I can find it. 2002 week 16. So this definitely must have Tualatin support. But other than that, this is quite uninteresting. Micro ATX, no ISA slots. But capacitors look okay, but this has those same Sanyo caps that worked on the Asus, but the capacitance was dropped below tolerance. So I think this should be recapped if this is going to be used, but I don't need to use it. All I need is to investigate those VTT. and perhaps some other. It's good to have at least one motherboard that does support Tualatin. Let me put something under here, maybe. No. I made this from baking paper. Let me see how the. I'm hoping this makes easier to find those correct pins. Reds are the VTT. Those definitely should be connected together, and they are. And I'm sure all of these are. Yes. But this blue one, this is HG1. This is VTT on Tualatin, at least according to the datasheet. But no. It's definitely not connected on the motherboard, the VTT. And this is exactly the reason why I'm doing this probing. So this is edge control on previous, but the Tualatin Pinout says this is VTT. But no. So you got to believe it's not connected. All right. Because if it's not connected, maybe we don't need to do anything about it. But I'm going to place CPU later, and maybe it's connected internally in the package. More of these VTTs, all the red ones. Yes, and another blue. This is the X34. Is it VTT or not? Let's see. Indeed it is. That's VTT. And that's VCC on the PPGA Celeron and reset on Coppermine. So if I want to, no, of course something needs to be done with it. I don't want to connect VCC to VTT, although they are very close to each other on Tualatin. But if you want to also use, and I want to use Coppermine and others on this Slotket, I don't want to break any compatibility. So that's something I really need to do something about it. So more red ones. This should be green one. I wonder what this was. Oh, this was RTT control, but let's forget it for now. It's one of those that you can do something, but you don't have to. Tualatin should work without touching that one. And that other green is also one of those control, same thing really. But these two, oh, actually let's take here. Oh, yes, there's connection. And there's as well, yes. These are the two pins, G35 and 37, that the guide says must be connected together, and indeed there's a connecting on Tualatin motherboard. And there's just one more. I can even see under this baking paper that there's a trace there, so I'm going to, just in case, probe from there. Yes, and that was last of the VTTs. So indeed they are connected. except this HC1 that was previously edge control. There simply isn't connection. But all the other VTTs were connected together. Now let's place CPU and see if things change. Too bad I don't have any Tualatin Pentiums, but these Tualatin Celerons really should be exactly the same except the front side bus speed. And of course there's the Pentium 3s with 512k gas. Those are of course different. But other than that, the pinout should be exactly the same. Now we have CPU there. But do we have connection? We do have. So it wasn't connected on the motherboard, but it certainly is connected on the CPU package. Now let's take another. Let's try how those C3s handle this thing. Are there any differences? I would think not, but you never know. That edge control pin is something that probably doesn't need to be touched anything. I think it was, I need to read the guide once more, but this was the Ezra-T. But the edge control, it's generated on the Slotket because it's not available on slot 1. And I think it's just resistor connected to something. Was it ground or probably it was. On the Ezra-T we do not have connection there. We do not. Let's take this 8-bit Slotket here. And VCC is not this one, but it should be this one. Yes, we do have 51 ohms. I think wisest thing would be to simply do modification to this pin. But the guide was correct. There is really 51 ohms. Let's probe the other Slotket, Coppermine Slotket that is. This is exactly the same kind. Let's start with the VTT voltages. Let's test all these red ones. That's not no, wait. Yeah, that's not connected. There's 56 ohms here between these two. But let's see. It's P5 and this should be VTT. There's 56 ohms. Ohms to this one. And no connection to there at all. Let's go there. This is something, was this something else? This was the detector perhaps. Connection. No connection. No connection. No connection. But this, what is this only? No. 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 No, nothing. This one is connected, but this one isn't. So these two are not connected on this Slotket. And there's nothing there. So that's about the VTTs. What about the reset that should be connected here? Was this one? 142 ohms between. Yes. The blue one is core voltage here. What about this Y33? Was it? Is it ground or not? What's here? Because it's already supposed to be something else on 80 ohms. If I'm on the ground, but I can get ground here as well. Let's say 80 ohms. So yes, there's definitely something on Y33. So I don't think anything needs to be done to that one. All right, let's. It's time to install pin headers for the jumpers. But before that, I'm going to replace those 3 capacitors. I'm going to use the same SMD 10 microfarad capacitors as I did when I recapped the Asus B3BF motherboard. There's already pads for the SMD capacitors, even though this Slotket uses through holes now, but this works really nice for us because you'll soon see how I'm going to install those headers. But first I need to recap this. Yeah, that's good. They are all in there now. So about these jumpers, I'm going to glue together this. I just happen to have these, and perhaps they're not too optimal. I already got them, so we have 9 jumpers. This is SMD pin header. You're supposed to place it like this and solder that one. But I'm going to place my jumpers so that I can solder 2 of those pins directly above those ground holes where the capacitors were. It will hold the header there quite nicely. And then I'm going to glue this on top of that. And I'm going to use some jumpers to help it when gluing this, so it stays in a correct position. But I need to make sure I don't short those upper holes. And also because this Slotket came with the cover, I need to make hole on the, but that's something I'll going to do at very last after this is tested and everything. And perhaps I should place some tape there so that I don't do any shorts or something like that. Let me see. Now I'm going to cut, and I need to make sure I don't cut any traces. Yes, that should do it. So let's solder that one. This will also hold the header in place quite nicely. It's not perfect, but we'll take a look. We need some grounds on this upper as well, so perhaps I'll make some support here, and we'll see how it turns out. The ground here, this ground pin, so this one, this one. Now the pins are now a bit longer than the others. I guess they moved a bit. That wasn't my intention, but is there a sort here now? Not that one, but it was these two. No. I think it's good. So it's time to glue this on top of it. Let's see how that goes. I need to be quite fast with this one. This is not good for applying small amounts of glue. And now quickly test jumpers, so it stays in correct position. Now here's our jumpers. Time to move on. And that would mean no, actually one of these is 22 microfarads. This is the other Slotkets, so the 22, maybe it's the one closest to socket. Yeah, and this is indeed 22. Guess I'll just have to replace that one. I have these big tantalums that I ordered by accident. Maybe they fit. Actually, yes, they do. They are just the right size. Actually, this is even better because less likely that I damage it when inserting cooler. Now the wires, and we have epoxy on some of those isolated pins, and PCB varnish on a couple of other pins. And the PCB varnish wasn't. It flows too freely and makes mess and goes where it's supposed to be. So, but you can solder through it, and now it's actually not so good thing, because if I'm going to solder it, well, I'm just going to solder it back on. So I'm going first. Let's take a look about those pins and how they look with microscope. Seems I forgot to turn on recording once again. I'm going to try to get the epoxy off on top of this pin, so I can solder at least something to it. You just can't see if it's good or not. All I can do is hope that something goes there. And some of these pins, I think 2 of them had PCB varnish, but I can't remember what 2. This I think was with epoxy at least. Perhaps the others. It's hard to see much of anything. In fact, this is such a mess. It's hard to make anything out of it. I think this pin was isolated with PCB varnish. I don't even clean that. Need to clean that as good as the others, but I can't get the protection tape if there's something like that floating on top of it. The epoxy sure is stronger. And those in the middle, that's where I use the PCB varnish. You can easily see it's more elastic than the epoxy. Maybe this helps. At least a bit. I think it might. Yeah, that's definitely quite elastic, that PCB varnish. Let's hope it won't cause any problems later. I'm going to take a piece of tape and push a hole with a needle. That's the way to do it. And now, can I place this tape with small hole on top of this pin? I can hardly even see the hole. It's not that easy. Looks good, actually, very good. This tape hopefully protects that I don't short that again. But there's a bit of the tip that hopefully there's enough that I can solder something to it, and hopefully it's clean enough. But if this was with PCB varnish, then the soldering shouldn't be hard at all. But with epoxy I don't actually know. I wonder, should I use solder paste? I have the good stuff, not the Chinese stuff. Let's see. And if I place it like this, there's way too much. We'll just have to see how this goes. Actually, I think it's stuck there. Very good, very good. Maybe. No. Well, it is there all right. But yeah, this is long enough, definitely. What about this tape? Should I simply leave it here and try to make holes, a couple of more holes for the next. I was thinking of replacing this tape to every pin, but I don't know. Do I have to do that? I should have placed this a bit better. If that's all. Or what is this actually? Let's see. Power, VTT power cord. Now there's hole. Yeah, it's perhaps I can't use this tape. It doesn't really stay there. Even if I get this soldered. No, the hole is too big. No, I can't use this. How can I even get this tape? Well, I guess the wire is soldered quite nicely because it stays there. Even though I'm trying to get this tape out of here. No. It came off, but not completely. Although this doesn't really matter, but it doesn't look nice. I wonder if I should place. Oh, let's leave that one. Can we see if I should place epoxy around? Well, it's hard to say anything about that one. Is it isolated or not? Let's take another piece of tape. I'm going to put in this one. If it maybe helps something, maybe not. Can I breathe in that one? Should I go this way? Well, it certainly isn't soldered properly. It's connected to something at least, but I don't know. How can I get this? Tape off there without damaging anything. Well, it is soldered, but next is going to be hard. It's right next to it. So maybe these two should have been tried to solder with one piece of tape. I think so. I think I'm going to try this method again. Doesn't look good, I know. But this hides everything, so I can't even see where I'm supposed to solder that one. I really don't. But you can see that the tape actually protects quite nicely. But no, I can see the hole is lost. It's there. Yeah, it was harder because I couldn't push this tape all the way down because there's so wire next to it already, so no, I need to be careful. Yeah, I was afraid it was going to do that. Should I simply try? If I... But I don't know, is it isolated now or not? It's soldered, yes, but and we're going to need, of course we are going to test this, but let's try to get that one more there before testing this. Where can I get VCC? There is our VCC B13, and do we have it on a green wire? We do not, so looks like it's isolated properly. No resistance at all. Very good, very good. So that's good. This mess here, before I break anything, I think I should perhaps glue this somehow. Maybe I should actually solder the other end now, before I'm going to have too many loose wires everywhere. But the orange is out, jumper 1. So first jumper, not jumper block. But let's see how the Tualatin support is near the PCB where we soldered those two grounds. So this orange wire should actually no, yes, it goes to the middle, of course. It goes to the middle. But I need that, I should solder that bottom one first, because otherwise I'm going to desolder the middle one. And that would be VTT. And where do I get that? Let's dip it to flux. Yeah, that's nice. At the other end, I certainly didn't think this mod would be so hard, but then again I'm taking the long route with jumpers, and I'm supposed to do the other Slotket as well. But I'm sure it will be easiest because we're going to optimize away some of these wires. That's the whole plan, at least. Now let's take some flux. No. That's better. And now this one coming from the isolated pin, this one goes to the center here. This is going to look really awful, I know. It's good this Slotket has the cover. I'm going to melt that plastic so easily, so I need to be fast when soldering these wires. Perhaps this one is better. Quite good actually. I hope I didn't glue these jumpers on there. That's something I didn't think of. But let's worry about that later. Now, I think that's all. But need to test. So, looks like our jumpers are where they're supposed to be. Next time going to glue this. I'm going to place these jumpers again to support it, and I think I should cut this tape a bit so I can glue it to the PCB. Actually, while the glue warms up, we might take final look with microscope. I cleaned this a bit. What is this yellow? Because it's almost looks like there could be short. Maybe I can cut it a bit. Much better. There definitely won't be a problem. Those two look real good. Of course, the flux isn't good here. If I'm going to apply PCB varnish or epoxy, I think PCB varnish might be better here, so I can fix this later. These are our VTT. That's real good. Absolutely nothing wrong with it. And these we've already seen, I think. It just doesn't look good with all the epoxy, but yeah, that's all. And can't really make much of this. It is what it is. Not really beautiful, but this is unconnected pin. Yeah, that is quite ugly, this ground wire that goes there somewhere. But if it works, that's all we really need. Now I'm going to glue those jumpers there next, if I'm not careful. But I think that's quite good. One final test before actually trying this. Yes, looks to be good. We don't have any short there. I think I can test this, but jumpers first. But actually I haven't even tested this one with the Celeron, so I'm going to place the jumpers, yes, but let's test the other Slotket with Celeron first. I want to be sure about these jumpers, but I'm quite sure it's now, and I also want to be sure that it actually supports the Celeron, but I can't see why it wouldn't. Oh no, one of the pins is down there. This happened in the very last, and I pushed those. It's dirt. It's supposed to be VTT, but does it get connection? I think it does, so I'm sure it works. Let's place a jumper there, and I'm not going to fix that one with all the glue in there right now. Let's take this one and this one. Oh, sorry. Yes, the jumper connects. So it's okay. So the Tualatin position is to the closer to the PCB, and the original position I'm going to place those VTT with red. So yeah, it's black jumper when either of these is ground, and red jumper when either of these is VTT. And actually this is VCC through the jumper, this green one, but well, this is now the original position, and now it should work. But let me clean everything and we'll continue from there. Alright, we now have the unmodified Slotket. Let's see what happens. It's 400. What else there is to say? Let's turn this off and try the other Slotket, the modified one, with the same CPU. This should work just like the other one. And soon we'll see what happens. Yes, we have postcode. Yeah, looks very good, very promising. But why did it get into the BIOS? How did it? GNU, we changed something. Of course we did change something, but oh, it was just took some time there with the drives. Maybe because there's no floppy drive connected or something. But yeah, promising. I'm still with the power supply that has connection issues here, so and yeah, it's just connection issues. But really, let's forget this Celeron. What I want to know, however, if we connect those unconnected VTT lines, this shouldn't matter anything to the Celeron. What about the reset 2? It's the jumper 5. Well, it simply doesn't do anything if I put it in the Tualatin position, because it's unconnected. But does it need to be ground for these older CPUs? That's the reason, because I can eliminate that jumper completely if it's not needed. Actually, I didn't get any postcodes, so I guess this needs to be ground. Let's try again. Yes, now we have postcode. Well, it was quickly solved. We need jumper for that, absolutely. But we don't need jumper for that one, and I didn't think we need one, but of course now looks promising. Celeron works. Not that we are really interested in that one. What about Coppermine, Pentium? And I'm sure now we need to move that to another position, although I'm sure I did try this here previously and it was on the down position, so well, let's try. And now let's see what happens. Postcode, yes. It took 66 megahertz by default, but that doesn't really matter what it takes because we can just set. But yeah, Coppermine works. Moment of truth next. Let's try the Tualatin position. Tualatin CPU with 1.5 volts first because that's least likely to cause any issues. All of them need to be changed. Every single one except that last one that's already in Tualatin position. That's definitely a jump I'm going to eliminate. For the next Slotket. Let's see what happens, if anything. Postcode, very good, but just one. This isn't too promising, but it could be that some bus speed jumper, who knows. Let's try the other position. Again, one postcode. Now it works. Yeah, it was that jumper. But what do we have now? Let's wait and see. Very good, looks promising. This is what it should be. 1.5 volt, yes, exactly correct. And there it is. 1200 megahertz Celeron. 256k cache. And we don't have power on the micro drive. I'm going to solder. If it's just solder, I don't know, but at least I've tried something. I think the connector simply doesn't fit properly. Drive wound, can we boot from it? We can, yes. Looks good. So let's go with Quake first. It's too bad I can't use the high-res mode with this Trident. But yeah, looks good. We can use the PC player benchmark, but it's not really the benchmarks I'm interested. Now we need to investigate those jumpers. What can be eliminated? It works, yes, it works. I know. First, let's try this G37 connection. Because, well, there's nothing the other side. It's supposed to require this and won't boot otherwise. And that's certainly correct. It won't boot, no postcode. Do you think it's time to test the C3? Let's first try this Ezra-T. We have postcodes, yes. Beep, very good. This was 1000 megahertz. Looks very good. Correct voltage, yes. C3, very good. But this one doesn't say, is it Ezra or whatever. Let's go to the... Now we can put... So maybe that did help, that reflowing those. Ezra, it says. But this is of course Ezra-T. We're not going to try any overclocking or benchmarks until both of these Slotkets are modified. But yeah, looks promising. Let's run Quake. Well, it's a lot slower, but that was expected. Completely expected. And it's of course not good idea to run this benchmark from that micro drive until its power management is disabled, but I'm going to use some hard drive when doing those better benchmarks and Windows benchmarks, of course. But we can see this works. It actually does work. By the way, do we have... Yes, it's here. Let's see what it says. Ezra-T detected. So yeah, set multiplier 3.0. And we're running at 300. We're running 300 at the moment, but we also need... This is what we really need. Yeah, looks promising. But SX40, that's... Not bad, I suppose, but then again, it's also close to the SX20, 486 SX25. That's actually ideal. So I think this might be real nice. Real nice. But of course, we're going to test all those better later. This is only to test that this Slotket actually works. And it certainly does. It certainly does. I can say that already. But Nehemiah, that's going to be next. And it's one of those with 133 frontside pass. Postcode. Yeah, we're running at lower clock at the moment. Actually, we can set maybe we should have set that 133 jumper, but actually let's save and try that jumper. Oh, let's see what happens. Postcode at least happens. It didn't go to the BIOS. No. Manual, yes, of course. Of course we can set that. What am I talking about? Yeah, looks promising. And again, I think we really did have bad solder joint. We should get much better. Yes, Nehemiah, it indeed is. We should get much better quake score now. Pretty much the Coppermine level actually maybe a bit better now because the Coppermine was underclocked. Actually, we don't even get the Coppermine result. We are under it. But it's fast enough, that's really all that matters. And we'll take... But this... Well, actually, let's see what it says. Yes, we can't set multiplier to 3 with Nehemiah. Seems to be 4 is the lowest. And that makes this not so ideal perhaps, but we're going to retest those everything. $533, but with L1 disabled. Now let's see. Yeah, SX33 or DX40. Here we are. And we can of course get it slower when we can change the frontside pass on the fly, but I don't have any utilities to do that at the moment. But looks promising, really does. Now, one final test, the other Celeron, and why it's important, because it has the problematic voltage. Now, what kind of voltage? 1.3, and that's completely wrong. But it posted. And this is exactly the issue why we have to ground the voltage ID2. Because sometimes it posts with 1.3 and it looks like that dynamic dyn OE jumper 1, even though we now have it correctly set, that wasn't enough. But it's, in fact, it's possible that it didn't post previously because this was wrong, but we can set it now. These old motherboards do not have that 0.025 or 25 milliwatt settings, so you have to choose either of these, and this is most likely the stable one. But it might be even undervolted, who knows. But we don't undervolt right now. But yeah, I guess that answers. I can't eliminate that voltage ID2. But it's up to you if you want to do it or not. But we are going to experiment this more. Celeron T. Fast, but what we really want is slow for this multipurpose. We can't really slow this down. Well, the L1 can be disabled, but... This is interesting. It froze. This was the only CPU that did that. But fast, yes, but... Now it won't post. It didn't post. Nothing. Well, we could have bad connection here as well because one of the pins was bent. But now, no, we have postcode. But it's stuck there. No, it went further. I think it actually tries to put with 1.3 volts, and yeah, we have that issue here. But if it posts, then this sets it to 1.5. But now let's place that jumper, because now with this 1.475 volt CPU, if I place this jumper here, so what I do is force voltage ID 2 to ground. It's not going to get the voltage it wants. Instead, it's now 1.65 volts, and it's going to post with that one. So the BIOS has to set it to something lower, but it still doesn't post. I wonder why is that. It didn't help at all. Maybe could this be the reason? But this, well, now it did start. Seems to be the only problematic CPU. Can we run Quake now? Too bad I don't have another CPU with the same voltage. This is the only one. So I can't be sure if this CPU has some issues or... But now it works. But last time it was at the end where it stopped working. Let's try one more time. But this voltage ID shouldn't even matter at this point because BIOS forced it to another value, and well, I can get core voltage reading easily because it's on top of that tantalum capacitor. And ground is of course easy to find. Let's see what our core voltage is. So here is plus and here is it's bit below 1.5, but it's actually a very good one. So definitely good. So the BIOS did set it. Very good. Now I'm going to, it seems to work. I'm going to remove that jumper once again and see what happens. It was this one. Well, we are posting at least. And of course we're going to measure. And if we get non-posting system at one point, I'm definitely going to measure voltage. Because it was so easy to find the core voltage here. So I'm still not sure what the problem was with this CPU. Was it this? But actually I'm hoping to have some problems here, but because if it works now, whatever it was, I don't know. Nothing, it's very good. No issues at all. But we can still check. I think the voltage, it should be the same because BIOS set it. No doubt jumpers. Yes, it's same. It's actually spot on what it's supposed to be, what is CPU. So yeah. Now every time I reset, it works. Maybe I need hard power off. Yeah, postcode. Yeah. Postcode. Previously we had issues more often than not. But yeah, postcode, yes. There's absolutely nothing wrong. So it must have been those bus. Getting warm, yes. But you can see it works. What else can I say? All of these CPUs work. Motherboard works, and especially our Slotket works. But now it's getting late, so I'm going to place the PCB varnish there, and let it dry and draw some updated instructions for the next Slotket. We'll take a look at those then. But yeah, this very good. I think this is the stuff I want to use here. Because if I need to fix something, I can easily solder. If I place epoxy here, yes, it is stronger, but if I need to do some fixes, one of these gets loose or whatever, then it's not easy fix anymore. Yeah, I think this is good. All it really needs is cover on, and of course I need to check these bus jumpers.